Soy Dora. Dora needs to find Diego in the cave. Oh no, it's too dark. Let's see if Backpack can help us.
Backpack, backpack.
Gracias, Backpack.
Ayúdame. How do I make it glow? Do you know how to make it glow?
I do.
To answer this question, we must look at fluorescence versus chemiluminescence. As we know from chapter 29, light waves are electromagnetic waves which are made of the electric and magnetic fields. The EM spectrum has a range of wavelengths and the visible spectrum has a range of 400 to 700 nanometers, the colors we see in the glow sticks. Light waves derive from photons, a unit of energy that is absorbed by electrons. This emits energy that causes fluorescence. To go deeper into this, we must look at the photoelectric effect. Fluorescence and chemiluminescence both use this effect, which is the emission of electrons when EM radiation or a photon hits a material. Electrons emitted in this manner are called photoelectrons. E is the energy of the photon that's absorbed or emitted. This is equal to h, the Planck's constant, multiplied by the frequency of the photon. Another way to find this energy is using wavelength. To convert wavelength to frequency, we use the equation c equals f times lambda. C is the speed of light. When solving for frequency, we get the formula c over lambda. Using this instead of frequency to find the energy, we will then get a derived formula of E equals h times c over lambda. There are many energy levels that the photoelectrons are emitted to. If there is energy emitted as the electron goes down energy levels, there is fluorescence. To determine if there's energy emitted, we must use the photoelectric equation. HF is the energy calculated that the photon gives to the electron in the orbital, and phi is the work to eject the electron. If the energy of the photon is greater than the work of the ejected electron, we get fluorescence as energy is emitted. We use the Rydberg equation, which is not in the scope of the class, to see the wavelength increases as the energy decreases of the emitted electron. So what is fluorescence? Fluorescence uses the photoelectric effect where the electrons get excited to a lower energy level and emit light. Fluorescence needs an external light source, and due to the photoelectric equation, the energy emitted is less than what was absorbed by the photon. On the other hand, chemiluminescence is the emission of light due to a chemical reaction. It is similar to fluorescence as the electron's excited state goes to a lower energy level, but instead of an external light source like fluorescence, we need luminol reacting with hydrogen peroxide to produce light. There are many medical applications as well. A biology application would be UV spectroscopy used to study conformational changes in drugs. A chem application is UV spectroscopy, where the electron goes from the highest occupied molecular orbital to the lowest unoccupied molecular orbital. Knowing all of this, to make our glow stick glow, we have to break the glow stick so that the luminol and hydrogen peroxide can react to the light. When there is more energy absorbed than the work ejected by the electron, this creates energy emitted by the electron and moves the electron to lower energy levels. This is not fluorescence but chemiluminescence because it uses a chemical reaction rather than an external energy source. This makes the glow stick glow.
That makes so much sense. So I need to put enough energy into the glow stick for there to be fluorescence.